Hi everyone, this is part two of work rate problems that I put of a little video series I'm putting together here. If you watched my part one, I showed you a little uh, shortcut that you can use. It was the a times b over a plus b that you can get from the movie Little Big League. They talk about it in there. Does it always work? No, it doesn't. But there are variations of it that can work. So let's take a look at one variation. This is one where you know the two individual times, but they're working against each other. For example, a swimming pool can drain in 12 hours with the hose used to fill the pool turned off. Now, if the drain is plugged, the pool can fill in 8 hours. How long will it take to fill the pool if the drain is left open? So the setup looks like this. Again, it's a work rate, so we're talking about job per time. So here's the rate for the hose to fill the pool, 1/8 hours. Now we're going to go subtract because they're working against each other, right? So we're going to subtract from that 1/12 for 12 hours for the drain to work. And it's going to equal 1/x. And that's x would be how long would it take if both the drain is left open and the hose is running. So the long way would be to multiply through by the least common denominator, which is 24x. So multiply through that. So 1/8 times 24x is 3x. 1/12 times 24x is going to be 2x. Don't forget it's subtraction there. And then 1/x times 24x is going to be 24. 3x minus 2x is just x, so you get 24 hours. The shortcut is very similar to the a times b over a plus b, except it's going to be a times b over a minus b. Slap some absolute values on that because you don't know if it's going to be positive or negative. If it comes out negative, just make it positive, and we'll see that be a negative here. But sure enough, 8 times 12 is 96. 8 minus 12 is a -4. 96 divided by 4 is 24. Boom, you're done. Just that fast. I know, it's cool, right? This formula will also work together if you have one individual time and then a time working together. Now, I'm going to go back to, if you watch part one of this video, I used the problem that where Greg can paint a room in 3 hours, Phil can do it in 5 hours. How long will it take working together? We came up with an answer of 1 7/8 hours. So let's take a look at what if you know Greg's time and you know the time together is 1 7/8, but you don't know Phil's time. Okay, well, that's what we're looking at here. Together, Greg and Phil can do this in 1 7/8 hours. Alone, Greg can do this in 3 hours. How long will it take Phil to do this in 5? So we know it's going to be 5, right? So let's set it up. 1/3 plus 1/x equals 1/15/8. So it's going to be kind of funky with that fraction in there, but really you can just flip that guy over and just make it 8/15, and that'll take care of that issue. And then multiplying by an LCD of 15x. So 1/3 times 15x is 5x. 1/x times 15x is 15. 8/15 times 15x is just going to be 8x. Subtract the 5x to both sides. 15 equals 3x, so x equals 5. So we got the right answer. So let's try that little shortcut. We're going to have to do the a times b over a minus b thing. And whenever they give you one individual time and they give you the time working together, you're going to have to use this approach to find that third time. And again, yeah, this is if they're working together. All right. As you can tell, because of that fraction, this is going to get messy. But a times b over a minus b would be 15/8 times 3 over 15/8 minus 3. 15/8 times 3, remember that's like 3/1. So really the 3 just multiplies to the numerator to give you 45/8. This 3 is like 3/1. You need to have a common denominator in order to subtract those guys. So 3 becomes 24/8. 15/8 minus 24/8 is a -9/8. Invert and multiply, we're looking at 45/8 times a -8/9 equals 5/1 times a -1/1. What happened there was 9 goes into this 45 5 times, and of course -8 and 8, they divide out and just gives you that -1/1 there. So 5/1 times -1/5 gives you -5 or 5. So you can get the same answer. Typically, the shortcut would work faster in this case if you didn't have that fraction to contend with. This may have been a poor choice in problem selection on my part, but you get the idea, I hope, in that this little shortcut is pretty handy. Now, I'm going to finish off this work rate video shortcut business by saying this. Will the shortcut always work? No, not always. In part 1, I showed where the 2 individual times were given, and you could use the shortcut to find the time working together, which you see right here. In this video, I used the shortcut right here. If you were given 2 individual times working against each other, you can use the shortcut there. You can use the shortcut if you know 1 individual time and the time working together. And what's the other individual time? And we see that working here. Not the best choice of videos, like I said, or selections, like I said. When the shortcut will not work is if you're seeing if one person's speed is 2 hours faster than the other person's speed, or if one person takes a job 2 hours longer than the other person to do the job, or twice as fast to do the other job. When they're starting to show comparisons like that, then your shortcut is no longer going to work, okay? And you're going to have to do it the long way that you see over here, for example.